Now I'd like to look at using the push buttons for input. We're going to do two things: count every time you push the button and build a die. So every time you push the button, I get a random die roll. To start with, you go to Bison Academy. Let's start with the first program, count RB0. That will count every time I hit port B pin 0. If I copy that, go into MVLab, create a new program, and this one's just going to be count. Count.asm. And I'll include in the project this file, delete the old one, add the current project. What this program does is every time I hit RB0, it counts. It starts out by making port A output, port B input. FF means all pin on tris B are 1 meaning input. Port C, D, and E are output. Everybody's binary. And starting from 0. This is where I count every rising edge. And as long as I hold down RB0 and it's a 1, I'm going to keep on looping. This is bit test, skip if clear. If port B pin 0 is clear, I skip out. If it's not clear, meaning I push the button, I will keep on looping. When I release the button, it comes down here. When port B pin 0 is a 0, there's a bit test, skip if set. If it's 0, I don't skip, and I keep on looping. As soon as I push the button, I skip out, and I increment. There I just found a rising edge, and I'll increment by 1 on the rising edge. Once I've found the rising edge, I'll then go back to main and keep on checking, looking for the next rising edge. This command right here is the increment port C, put the result in port C. Basically count. If I compile that, F10, and then download that code to the processor. This was under my documents, 376 assembler count.asm, count.hex. There's my program. It is now counting every time I hit port B pin 0. Currently the count is 0. We hold the button down. There's 1, 2, 3, 4. Got a double count there. 5, 6, 7, 8, 9, 10. Okay, so there I'm counting on port B. Next, let's do a random number generator. Going back to Bison Academy. Let's do a random number between 0 and 255. Copying that code over. I'll just blow out the old code, start over. This is almost the same program. The difference, though, is when I hold down the button, it doesn't skip. It increments a variable called die, putting the result in variable W. And the result was 7, so I'm going to count 0 through 7. When I get to 8, it'll clear out the high bit and just go back to 7. And put the result in variable die. I then move that to port C. So what's going to happen is every time I hit port B pin 0, it's going to count really fast. Not 8. When I release, whatever number I counted to gets sent to port C. That's an 8-sided die using the person as the random number generator. How long we'll hold it down is basically random. If I compile that now, and send that to the processor, here's your new code. Now what happens, it's holding a number, currently number 7, and hit down RB0, it's counting really fast. You can't see it because it's counting so fast. When I release, that's the random number, where I got the number 1. Counting fast, 6, 6, 2. This is one way to generate a random number on a pick. Note that if the number I'm generating is a power of 2, such as 8-sided die, 6-sided die, and so on, it's fairly easy. If I want to have a number 0 through 7, just end it with 0, 7. Anything end 0 is 0, anything end 1 is 1. Doing mod 8 is actually easy. If I want to do mod 6, that's actually kind of hard. What I have to do is increment, then check, is the result equal to 6? If it is, then clear it, otherwise don't clear. We'll leave that as a homework assignment. But what you wind up with is basically a random number generator, an electronic die.